In our last video, we introduced electrical circuits. In this video, I want to focus more on three important terms that you will see whenever you're talking about electrical circuits and their relationship to one another. The first term I want to introduce is voltage. And voltage is usually represented by a big V. And the typical unit for voltage is volts. The next term that you're going to see is current. And current is usually represented by a big I, and the typical unit for electrical current is amps. And the third term is resistance, which is usually represented by a big R, and the typical unit for describing electrical resistance is the ohm. Now, all three of these terms here are related by a simple equation known as Ohm's Law. And what Ohm's Law says that electrical current, big I, is mathematically equal to the voltage divided by resistance. So this here is an important equation that you will see whenever you're dealing with electrical circuits. Before we do some mathematical problems with this equation, I want to briefly explain what each of these terms mean so that you guys will have an intuitive understanding of them when you see them. I want to begin by describing the relationship between voltage and current. And in order to understand the relationship between these two terms, it's helpful to think of an analogy. So this analogy is going to help us understand what's happening in electrical circuits. Imagine here that I have two giant water tanks, a tank on the left and a tank on the right, and a giant pipe connecting them. And imagine that I put water in both these tanks, but I put more water in the left tank than the right tank. And of course, there's this valve here that I'm able to open and close. Now let me ask you guys a question. What's going to happen the moment that I open this valve? Well, that should be obvious. As I open the valve and allow water to flow, water is going to flow from the left tank to the right tank until the water reaches equilibrium, and so at that point the flow would stop. So as a general rule, you guys should know that water always flows from high pressure to low pressure, and this is exactly analogous to the flow of electricity. So if we have a battery, all batteries have a negative end and a positive end. The negative end is usually referred to as the region of high potential, and the positive end is usually referred to as the region of low potential. So if I was to connect a light bulb and a copper wire to this battery, just as water flows from high pressure to low pressure, so electricity always flows from high potential to low potential. And so the difference in potential energy between the negative end and the positive end is what is known as voltage. And the rate of charge flow, in other words, the rate by which these electrons are flowing through the circuit, is what is known as current. Now, in our water pipe analogy, the flow of water stops immediately as soon as the pipes are in equilibrium. However, that's not the case with electrical circuits. The electrons don't stop flowing immediately, and the reason why is because there are chemical reactions in the battery that allow the electrons to continue to circulate throughout the circuit. And hopefully it should be obvious in this analogy here that the greater the difference in pressure between the left tank and the right tank, and that means the faster the water will flow between the two tanks. And that is the same thing in an electrical circuit. If you have two batteries and one battery has a greater voltage than another battery, so this battery on the right is 9 volts and the batteries on the left is 6 volts. And if I was to connect a copper wire to both batteries, that means the 9-volt battery will have a greater charge flow than the 6-volt battery. In other words, it will have a greater current. So that's the relationship between voltage and current. As voltage increases, current increases. As voltage decreases, current decreases. Let us now move on to talking about the relationship between resistance and current. And in order to understand electrical resistance, let us go back to our water pipe analogy. So in this analogy here, imagine that I decided to add a filter to my water pipe. Well, what do you guys think this filter would do to the flow of water? Well, that should be obvious because the filter acts as some sort of barrier. The filter would decrease the rate of water flow. And it should be obvious that the more filters I add to my water pipe, the more and more the rate of water flow would decrease. So that analogy helps us understand electrical resistance. So the filter resists water flow, so adding a resistor or a device to a circuit resists the rate of charge flow or resists the flow of electrons. So in other words, as the resistance of a circuit increases, the current decreases. And if you could decrease the resistance of a circuit, you would increase current. Now, sometimes you will see Ohm's Law written in this form, and sometimes you will see it written in this form. Just know that they mean the same thing. This equation is nothing more but this equation rearranged. Voltage is equal to current times resistance. Now, in closing this video here, I would like for you guys to go to this website right here so that you guys can kind of see Ohm's Law in action. Notice here how we have some batteries connected to a wire. And I want you guys to notice what happens to the current going through the wire as we increase the voltage of the batteries, but yet keep the resistance of the circuit constant. So notice here, as voltage increases, current likewise increases. As voltage decreases, if you notice, the value of the current also decreases. Now let us hold voltage constant and change resistance. Notice as we increase resistance, notice how current decreases. And as we decrease resistance, notice how current increases. Lastly, before I close this video here, I want to say something about this diagram. Sometimes whenever you guys see electrical circuits drawn, you will see the arrows pointed from the positive end toward the negative end. And the reason for that is because of traditional and historical reasons. Whenever electricity was first discovered, scientists thought that it was positive charges that were flowing through the circuit. We now know that it's not true. We now know that it's actually electrons or negative charges that is flowing. So in reality, the flow is going from this end to that end. So even though you see arrows pointed in this direction, just know we just draw it that way because it's traditional to do so, even though this diagram here doesn't really depict the actual direction of the electrons flow. Okay, so I'm going to go ahead and pause this video, and shortly I'm going to post another video that deals with more calculations involving Ohm's Law. If you guys have any questions about this video and the topics involved, please don't hesitate to contact myself or anyone else in the physics department. Have a good day, and bye.